Okay, and the last example we're going to be looking at, again, we're looking at all the factoring methods together, okay, is going to be this. F of x equals 2x cubed plus x minus 3. So let's go up here. Let's see, does it have a GCF? No. These two have x's, but that one doesn't. Sum of cubes or difference of cubes? No, because it has 3 terms and not 2. It's not a quartic, doesn't have a 4, so we're going to have to jump to step number 5 here and use the rational root theorem to find a rational root. Once we find a rational root, then we can find the rest of the roots. Okay? So again, I'm going to be doing factors. I'll tell you what, rather than even writing that out, I'm just going to circle them. Factors of -3 and over 2. Okay? So factors of -3 are -1 and 3, or -3 and +1. Factors of 2 would be 1 times 2, or -1 times -2. So here's my possibilities. -1 divided by 1 is -1. -1 divided by 2 is -1/2. -1 divided by -1 is +1. -1 divided by -2 is +1/2. Then I got this 3. 3 divided by 1 is 3. 3 divided by 2 is 3 over 2. 3 divided by -1 is -3. 3 divided by -2 is -3 over 2. And from here, I'm going to use my calculator. And I'm not going to make you write them out again, but just know that when you test each one on the calculator, that the one that turns out to be the solution is 1. That's the one that when I plug in a 1 into this polynomial for every x value, the remainder is 0. So I know that that one's a factor. Okay? And then from there, I'm going to use synthetic division to find the other factor, or I'm sorry, not a factor, but a root. Then I'm going to find the factor, the other factor, using synthetic division. And after that, I will solve that one using square roots or quadratic formula. So be very careful on this one, because remember we talked about how you have to use a placeholder if this one skips something. And because it went from 3 to 1, it's skipping x squared. So I'm going to need to put a 0. So 2, 0, 1, and -3. I'm going to add down. It's a 2. 1 times 2 is 2. Add down. That's a 2. 1 times 2 is 2. Add down. That's a 3. 1 times 3 is 3. 0 remainder. We want to have a 0 remainder because we know it will always be a 0 remainder. Okay? Because we automatically know that this is a solution. Therefore, it is a solution. There will not be a remainder. Okay? And then again, at this point, we're going to plug back in our variables for this, and then we'll solve using, looks like we're going to have to use quadratic formula. So we have x cubed, so it's going to be 1 less than that, so x squared, plus 2x plus 3. So there is my solution. That's my other factor. Now I have to take that and I have to find out what the real roots, or what the roots are using that. So I'm going to use the quadratic formula for this one, because this does not factor easily, because I'd have to do slide, divide, bottoms up. So use quadratic formula. -b would be -2 plus or minus the square root. B squared is 2 squared minus 4 times a, which is 2, times c, which is 3, all over 2 times a again, which is 2. All right, so I'm going to come up here now. It's going to simplify a little bit. I'm going to have -2 plus or minus the square root. 2 squared is 4. And then minus something. If there's only one minus, that means one negative, and this is still going to be a minus. 4 times 2 is 8, and 8 times 3 is 24. And then 2a would be 4. And that's pretty easy. That's -20. over 4. So at this point, the negative 20 is going to be able to jump out. Just remember that this is like negative 1 times 4 times 5. So the 4 is going to jump out as a 2, and the negative 1 is going to jump out as an I. And you probably will recognize that there are some things that cancel. If all three whole numbers have a common factor, you have to divide it out. So they can all be divided by 2. So that's going to make this become a 1, and this is going to become a 1, and this is going to become a 2. So my solution is negative 1 plus or minus I square root of 5 over 2. So one root is x equals 1. The other roots, there's 2 of them here. Negative 1 plus I square root of 5 divided by 2, and negative 1 minus I square root of 5 divided by 2. And those are the values that you're going to have for your root or zeros of the function, or another name for all of those is solutions for the functions.